In 5.1, we are going to do more of the same that we did in chapter 4.3b, where we use fundamental identities to simplify the expression. Simplify sine of x cosine squared x minus sine of x. So when I see this, I notice that I have something minus something, where they have a common factor of sine of x. So when I take out the GCF, or take out the common factor of sine of x, I end up with sine of x times the quantity cosine squared x minus 1. Notice here we get cosine squared x minus 1 using one of the Pythagorean identities here. If I get cosine squared x minus 1 and I subtract the sine squared x to the other side, it's equivalent to negative sine squared x. Okay, so I went ahead and substituted negative sine squared x for cosine squared x minus 1, and when I multiply these together, I have a combined total of 3 sine of x is being multiplied together, so it's sine cube x, but it's negative. So your final answer is negative sine cube of x. Remember, this is negative times sine of x times sine of x times sine of x. Go ahead and try this problem. Simplify. The correct answer is negative sine of x. So notice you have a GCF, or a common factor of cosecant of x. And so when I factor that out, I end up with cosine squared x minus 1. And if I distribute, right, I should get back to what I had before. And notice that cosine squared x minus 1, right, cosine squared x minus 1 is equal to negative sine squared of x. So I replace that. And notice that cosecant of x is equivalent to the reciprocal identity 1 over sine of x. So I can replace that there. And when I multiply these together, right, one of the sine of x's cancel out, leaving me with negative sine of x. Right, remember this is like over 1. So you have negative sine squared x over sine of x. And one of the sine of x's cancel out. Here's an example. Factor secant squared x minus 1. So we're factoring a difference of two squares. Notice I have sine squared x minus 1. So I can factor this, right, when I have a difference of two squares, they're going to be conjugates. It's going to be secant of x plus 1 times the secant of x minus 1. That is my final answer. Again, notice if I were to FOIL, get secant squared x, the middle terms cancel out, minus and a plus, and then I get minus 1. Factor 4 tangent squared x plus tangent of x minus 3. So recall that if you had just 4x squared plus x minus 3, think about how you would factor this, right? So if you're using this method here, you multiply the a and c value, getting negative 12, bring down the b value, two numbers that multiply to negative 12 but add to 1, that's going to be 4 and negative 3, divide by the a value, so you end up with x plus 1 times 4x minus 3 as your factorization. Okay, again, you want to double check that this is true. Do a quick check. 4x squared, you get negative 3. Do a smiley face check. That's positive 4x, negative 3x, giving me a positive x. So you know you factored it correctly. Now, notice that here, instead of x, though, we have a tangent of x, right? Because the tangent squared x and just tangent of x. So we're going to get the same thing. So our answer will be, everywhere we see x, we're going to substitute with tangent. So our answer will be tangent of x plus 1 times 4 tangent of x minus 3. Again, you can check your answer by FOILing if you wanted to. You get 4 tangent squared x, and then you get negative 3. And you get 4 tangent of x minus 3 tangent of x, giving you a middle value of positive tangent of x. Go ahead and factor 1 minus cosine squared x. Here's your final answer. It's a difference of two squares, so you should get two conjugates, right? 1 plus cosine of x times 1 minus cosine of x. Go ahead and try this problem. Factor 2 cosecant squared x minus 7 cosecant of x plus 6. The correct answer is cosecant of x minus 2 times the quantity 2 cosecant of x minus 3. Just a reminder that these two chunks can be switched. That's fine. 2 times 3 is the same thing as 3 times 2. So something you want to consider is to factor this as if it were just like an x squared. So instead of x, you're going to have cosecant of x. Right? And when you factor, whatever method you're using, guess and check, or the x method, or the x box, or grouping, you end up with x minus 2 times 2x minus 3. And instead of x, you replace it with the common trig term of cosecant of x. So cosecant of x minus 2 times 2 cosecant of x minus 3 is your final answer. Factor cosecant squared x minus cotangent of x minus 3. So notice that unlike the previous problems we were doing where you had common factors here, like all cosecants of x's or cotangent of x's, these are different. So the first step is to rewrite the expression using a single trig function. So all in terms of cosecant x's or cotangent of x's. So when I see cosecant squared x and cotangent of x, I remember that this is one of the relationships I have, right? I caught one fish. Cotangent squared x plus 1 equals cosecant squared x. So where I see cosecant squared x, I'm going to substitute or replace with cotangent squared x plus 1. And when I simplify like terms and put it in decreasing order of power, I end up with cotangent squared x minus cotangent of x minus 2, right? 1 minus 3 gives me negative 2. Now I have everything in terms of the same trig function, so now I can do the same thing as I did before and factor. And the way I would factor this is to think of it as x squared minus x minus 2. And when I factor that, I end up with x minus 2 times x plus 1. And then everywhere I see x, I would substitute it with my common trig function of cotangent of x. And I get cotangent of x minus 2 times the quantity cotangent of x plus 1 as my final answer. Go ahead and try this problem. Factor secant squared x plus 3 tangent of x plus 1. The final answer is tangent of x plus 2 times tangent of x plus 1. So first up is to notice that my terms are not in terms of the same trig function. One's in terms of secant of x, the other is in terms of tangent of x. So try to come up with a relationship that connects both of them together. So remember tan in 1 second, that's one of the Pythagorean identities. So everywhere I see secant squared x, I'm going to substitute it with tangent squared x plus 1. Combine like terms, right? 1 plus 1 is 2. Put it in decreasing order of power. And I am ready to factor. So again, think in terms of x squared plus 3x plus 2, which factors to x plus 2 times the quantity x plus 1. And then everywhere you see x, you substitute it with tangent of x.